Hello everyone, welcome back to my additional max and max channel. For your information, this is the most favorite topic for every student, I guess. This topic is very important as it's actually involving hot question because it is actually solving problems in our daily life. So focus to this topic and ensure that you are actually can score perfectly for this topic. So that is why I am sharing with you the most impressive video. Please enjoy the video teaching conducted by US teacher. Have fun.
For this question here, we have two tables of values, okay? And the task is to determine whether they represent this thing called the direct variation. So let's quickly go over this. What is this thing here? Let's quickly go over the definition of direct variation. Okay, a direct variation is when a variable, let's call it y, varies directly with x, another variable, with a constant variation of k, a constant. Okay, so translating this into math terms, we can generate an equation like this, like this guy here. Okay, we have a variable y equals k, the constant, times another variable x, right? Where k cannot be 0. Okay, k can be any number. It can be positive. It can be a positive number. It can be a negative number. It can be a decimal number, a fraction, a root number, okay, anything but 0. Okay, so for a table of values to be considered a direct variation, it needs to satisfy this relationship. Okay, it needs to satisfy this equation. Okay, where whatever x we plug in, we're going to multiply a constant k to get its corresponding y value, and this relationship would have to be consistent throughout the entire table of values. Okay, then we can call that table of values a direct variation. Okay, we can call a table of values. We can say that the table of values represent a direct variation. Okay, so going back to this question here. Okay, let's focus on our first table first. Okay, in order for this table of values to represent direct variation, we need to check whether its values actually satisfy this equation or not. Okay, so y equals kx, k times x, where k cannot be 0. Right? So how do we determine that this table of values actually satisfy this equation? So it's the same as asking, is there a k constant that can be multiplied to our x values of the table to get their corresponding y values. Right? Does such a k constant even exist? Okay, that's our question. That's our main question here. So how do we find this k constant? How can we tell that such a k constant exists? Well, we simply need to look at this equation and we'll perform some algebra, okay, on this equation. So we want to find what the k is, right? We want to find whether a k exists. So in other words, we want to solve for k, right? So if we want to solve for k, that means we want to isolate k, right? So isolating k here, that means we don't want anything attached to k, so we're going to move this x to the left side, and that means we have to divide both sides by x. So dividing both sides by x, what do we have? We have y over x on this side. These two x's got cancelled, so we are left with k. Right? So to find the k, we simply need to find the ratio between the y and the x. Right? The variables. We simply need to find the ratio between the variables and check if this ratio is consistent, if the ratio is consistent throughout the entire table. Right, so we simply need to take y, the y value, divided by its corresponding x value. Okay, so let's see. Let's look at our first column here. Right, when we have an x value of 1, we get a y value of 6. So to find a k value with these, to find a k constant with these two values, right, using this new expression that we've just generated, okay, we simply need to plug in 6 into y, right, and 1 into x, right? So we will get this, right? 6 divided by 1, and it's going to give us 6, right? So the k we've derived using these two values is 6, right? Now, moving on to the next column here, we need to have the y value, right? We need to plug in 12 into this thing here, so 12 over our x value this time is 2. So then we're going to have 12 over 2. Right, and this gives us 6. Right, we have a k value, we have a k constant of 6 again. Okay, moving on, we're going to have 18 divided by 3. So this is clearly 6. What about this guy? 24 divided by 6, that's also going to be 6. I'm just going to put a check mark here. Okay, 24 over 4. Right, 30 over 5, that's also going to be 6. Right, 30 divided by 5. 36 divided by 6, that's also going to give us a k constant of 6. So we have just verified that the constant k, what do you guys call it? The constant variation. Right, the constant variation is indeed consistent throughout the entire table of values. And therefore, we can conclude that this table of values represent direct variation. Okay, so this guy here, we can say a big yes here. Okay, moving on to our next table here, we're going to use the same method, the exact same method to determine whether this table represents a direct variation or not. Okay, we're going to use this same method here. Right, so having a y value divided by our x value, we'll get negative 1.2. Let me change the color actually. So negative 1.2 divided by positive 1. Our k value here would be negative 1.2. Right, again, we want to see whether we actually have a consistent constant variation throughout this table or not. Right, if we do have a consistent k, then that's good. We have a direct variation. If we don't have a consistent k, then we're not going to have a direct variation. Okay, so that's the first column. Second column here, we are going to have negative 2.4, right? The y value divided by its corresponding x value. So the y value here would be negative 2.4, so divided by 2, its x value, we will get a k constant of negative 1.2, right? And moving forward, when we have a y value of 3.4, okay, we're going to have to divide this by 3. And as you can see here, Okay, well, let's do the math here actually. Okay, this, if we divide this by 3 using long division, okay, we can plug in a -1 here, so okay, we can get -3, right? And pulling this 4 downwards, what are you going to do? Well, we can have 1 here, and then continuing, we're going to have 3, and this is sufficient to tell, if this is sufficient to conclude that our k value is not -1.2, right? Because, well, evaluating this fraction here, we'll actually get a k value of -1.13, and it's going to go on forever, right? Because our next value would also be 3, right? And it continues forever, right? Okay, so moving on to the next column here, we're going to have -4.8 divided by 4, and this is going to give us a k constant of -1.2, right? We can use long division to check it. Well, let's do it really quickly here. So we have -4.8 divided by 4. So this is going to be -1. So, well, we can have -1 here. So then we're going to get -4. Pulling down the 8, we get 2 here. Don't forget a decimal dot there. So we get 8. We get a remainder of 0. And the k constant is indeed -1.2. So same thing with the last column here. When we have -6 divided by 5, we're going to have a k constant of -1.2. So what this tells us is that we have one weird guy poking out here, right? This guy has a k constant, right? This column has a k constant of -1.13, right? The ratio here is not what everybody else is having. Right? Everybody else has a k constant of -1.2, and this weird guy here has a constant of -1.13. And this means, okay, this indicates that this table of values does not represent direct variation, okay, because the k constant, the constant variation, is not consistent throughout this entire table of values. Okay, so we have no. For this question here, we want to determine whether these equations here, or each of these equations here, represent direct variation. Okay, so let's quickly take a look at the definition again. Okay, so in order for an expression to be considered as a direct variation, we need this to hold, right? Y varies directly with x or as x, right, with a constant variation of k, where k cannot be 0, right? K can be a positive number, negative number, fractions, decimal numbers. It just can't be 0. This cannot be 0, right? So as long as this expression here, as long as this relationship holds, right, as long as this equation is satisfied, we have a direct variation. Okay, so let's go back to the options here. So in order to determine whether each of these equations here represents direct variation, we simply need to compare each of the equations with our direct variation expression, right, where k cannot be 0. Cool? So let's take a look at our first option, okay, option A. Our first option here, we have y equals 2, so I'm just going to put it on the left side of this table here. Okay, so comparing these two expressions, what's the difference? Well, if you take a look at our left side here, right, we only have y equals 2. Right, we have a constant. We have a constant here, but we don't have an x. So this guy is not a direct variation. Okay, not a direct variation. If this guy has an x here, then yes, it would be a direct variation. But right now it only has a constant, right, 2. It only has the k, so this is not direct variation. Okay, so let me erase this thing and move on to our next choice here. Okay, let's look at our option B. Okay, we have y equals, well, let's take a look at this equation here. Right? Y equals 3.1x. We know that we have a constant multiplied to our x here, right? So this is k. 3.1 is actually a k. But is k is k 0? Obviously not, right? K is 3.1. It's a positive number, and that satisfies our conditions here, right? So we have y equals k times x. Okay, that's cool. It matches with our right side. This is representing direct variation. Right, so B is a direct variation. Let's take a look at our option C now. Okay, option C, we have y equals negative 7x over 9. So right now we can kind of see that we have a fraction here, right? Negative 7 times x over 9, right? At first glance, it doesn't quite match with what we have on the right side. But if we rearrange this equation just a little bit, okay, let's see what happens. Right now we might be inclined to think that we have negative 7x and negative 7 times x divided by 9. But we can think of it this way. We have negative 7 over 9 times x. They mean the same thing. Right, so if we rearrange it this way, then we can see pretty clearly that this thing here, this fraction here, is our constant, right? Our constant k. So right now we have y, right? We have y equals this constant here multiplied to our x here. Right, so this matches with what we have on the right side, which is our direct variation expression. So this guy here is actually a direct variation. Okay. So far we have 2. So let's look at our option D. Okay, x times y equals 191. I'll write it down first. X times y equals 191. So let's take a look at our left side here first. Right, we have x times y, right? All the variables are on the left side of this equation equals 191, a constant. So at first glance, we know that this doesn't match with this, right? But can we rearrange this equation here so that we have something in this form? Well, let's see. Let's find out. Okay. Our direct variation expression here has a y isolated on the left side, right? So let's try to isolate our y here. Okay, by isolating y, we need to divide both sides by x to move this x away. Right, so dividing both sides by x, we're going to have these two x's canceled here, so we have y equals 191 over x. Right, and comparing this expression with this expression here, okay, we don't have a match. Right now, this x is in the denominator, right, of this expression here. We have x in the denominator, as opposed to having x multiplied by constant everything in one line. Right, so they don't match. Okay. Later we'll know that this is actually, in the other videos, I'll talk about this form. Okay, this guy here is what we call an inverse variation. Okay, so whenever we see an x in the denominator, we call that an inverse variation. Okay, so we'll talk about this. We'll elaborate on this in the other videos. Okay, so let's erase these things here. And we found out that D is not a direct variation. Right? It's called an inverse variation, which we'll talk about later. Okay, so our last choice. Okay, y equals 8x plus 5. Well, at first glance, we can already tell that we don't have a direct variation. Right? We can tell that this guy does not represent a direct variation because it's not in this form. Right? It has an extra term here, plus 5. Right? If this guy doesn't have this plus 5, then yes, we can say that this guy represents a direct variation because 8 is our k. Right? 8 is now our k. Right? Then we have y equals k times x. So yes, this is a direct variation. But because of this 5 here, We can't call this guy. We can't say that this guy represents direct variation. Right? In fact, whenever we see an equation in this form, we can say that we're looking at a linear function. Linear function in slope intercept form. Okay, so an expression, an equation in this form, y equals mx plus b, is what we call a slope intercept form. Okay, where m is a slope, it is m here as a slope, and x is just a variable, b is a y-intercept of the function. Okay, so if you want to learn more about this thing here, linear function, slope-intercept form, feel free to check out the other videos. And for this question here, we are done. Okay, we only have two choices here that actually represent direct variation, which would be B and C. Okay, two rows. The first row here we have a bunch of x values, and there's an m right in between them. Right. For the second row here we have n32 and 64. Right. So how are we going to find these two missing values? Well, we have one very important piece of information right here. And this first phrase, it says that variable y varies directly with x. So this is direct variation. Right? So under this scenario here, we can generate an equation. Right? How is that going to look like? Well, let's go back to our notes here really quickly. Right, so when y varies directly with x, with a constant variation of k, we can write this down. Right, y equals k times x, where k cannot be 0. Right, so this y, the thing that varies directly with another variable, this first y here goes into right here, right, y equals k times x, which is the second variable in the statement. Right, so all we need would be that equation, would be that expression here. So let me write it down. Okay, we have y equals k times x, then we have k not equals 0. Right. So knowing this important piece of information, okay, we can figure out. We can solve for m in it. Okay, but that would be probably the second step. What is the first step though? Notice here we have three pairs of points. Right? If we take a look at this column here, we have 1 and n. Right? This thing here is missing. We need to solve for this. Right? This guy here is missing, so this pair we have one variable we don't solve for. But for this last pair here, right, this last pair, we're given both the x and y values. Right, so how is that going to help us? Well, using these two values here, we can figure out what k is. Right, so let's do that right now. Okay, so using the last pair here, using this pair, let's try and find out what k is. Right, how should we do this? How should we do this? Well, we can just plug things in, right? Y is 64. Then k is something we want to find, right? X is 8. Okay, so solving for k would mean that's just algebra. We just want to isolate k. Okay, we're going to divide both sides by 8. So we're going to get 8 equals k. Right? These two 8's got cancelled. Right, so our k is 8. Right. So we note that down right here. Cool. Now, with this information, we can figure out what m and n are. Okay, almost got it wrong there. So let's solve for n first. Okay, so to find n, we simply need to plug things into this equation again. Right? Our y value this time would be n. So I'm gonna have n here. Okay, equals k, which is our. Actually, I'm just gonna write down the entire equation first, and then we can plug things in. Okay, we have y equals k times x. Right? Our y this time would be n. Right? So we have n equals n equals, okay, our k, which we found out was 8, okay, times x. What is our x value? That's 1. Right, so we have n equals 8 times 1. That's pretty straightforward. Right, n equals 8. Okay, so let's figure out what m is now. Okay, let me do it in this color. Okay, so for m, let me write down the equation. So we have y equals k times x. Okay, so our y value this time would be 32. Right, so we have 32 here equals our k, which is 8. So we have 8, right, times x. Our x value would be m. So very straightforward. We just need to plug things in. Right, so to solve for m, we need to isolate m. Right, that means we need to divide both sides by 8. And that's going to give us, well, 32 divided by 8, that's going to be 4. Right, so m is 4. And we're done.
Thank you so much, sir, for your impressive teaching method. Till then, I shall see you all in my next video teaching. Bye bye and have a nice day.